As I mentioned previously, the organizer secretes BMP inhibitors that allow the organizer around it to become neural tissue, and this has been shown through a series of experiments. These images are from an experiment in which Xenopus eggs were exposed to UV radiation, and that UV radiation prevents the cortical rotation. Since the cortical rotation doesn't happen in these UV-exposed embryos, the embryos become ventralized. They form a belly piece as shown here at the top. If these embryos are injected with Noggin mRNA, they develop dorsal structures in a dose-dependent manner. If you inject too much Noggin mRNA, you end up with a dorsal anterior tissue and no ventral or posterior tissues. Part B of this figure shows the location of Noggin expression by in situ hybridization. So what we're looking at here, the dark staining, is Noggin mRNA. As you can see, Noggin initially accumulates in the dorsal marginal zone. When the cells involute as gastrulation begins, Noggin mRNA is seen in the dorsal blastopore lip. As gastrulation proceeds, as these cells are migrating under the presumptive ectoderm, Noggin is expressed by the cells of the presumptive or the precursor of the notochord. So it's being expressed by the cells of the organizer, the precursors of the notochord and the head endomesoderm. And those cells are migrating beneath the ectoderm. So Noggin acts by binding to BMPs and preventing them from binding to their receptors. Like Noggin, the inhibitors chordin and follistatin are also expressed in the dorsal blastopore lip and later in the notochord. Together, these BMP inhibitors secreted by the organizer keep the ectoderm from becoming epidermis, and in that way they allow these cells to become the nervous system. So what is it that makes the neural fate the default fate of the ectoderm? Well, as it turns out, the earlier beta-catenin signal induces the expression of the organizer transcription factors, Siamois and twin, which act together to activate genes that induce the formation of neural tissue. However, since BMPs can suppress the neuroectoderm genes activated by Siamois and twin, the BMPs have to be blocked by the inhibitors that are secreted by the organizer. In the absence of BMP inhibitors, as shown here in Part B, the neural tube, which you can clearly see labeled in the control embryo, doesn't form. On the other hand, blocking BMPs completely results in the entire ectoderm becoming neural. So the epidermis is instructed by BMP signaling, and the neural tissue forms or is allowed to form because the organizer secretes BMP inhibitors that protect that tissue from BMP and allow it to become neural ectoderm instead. As we'll see, the role of BMPs in inducing the skin ectoderm, the epidermis, and of BMP antagonists in allowing the specification of the nervous system by protecting the ectoderm from BMPs is conserved across animals.